In this video, we are going to solve some problems using force and energy and work. First problem. An object weighs 2.75 times 10 to the 5th newtons on Earth. So on Earth, we're 2.75 times 10 to the 5th newtons. Its position is given by R equals 0.020 meters per second cubed t cubed I plus 2.2 meters per second tj minus 0.060 meters per second squared t squared k. What is the net force on it at t equals 5 seconds? So we are tasked to find force at t equals 5 seconds. All right. The first thing we are given, we need to find the mass. F equals ma. We are given the weight. So from the weight, we will determine the mass. So mass, weight equals mass times g. So I'm going to divide weight by g to get mass. So I've got mass equals 2.75 times 10 to the 5th newtons divided by 9.8 meters per second squared. And my mass is 2.8 times 10 to the 4th kilograms. All right, next thing. All right, we want to know its position at t. All right, it's the net force on it. Sorry, we're looking for the net force on it at t equals 5 seconds. We are given a position vector. Now we will have to take the derivative twice to get the acceleration. And from that, we will use Newton's second law. Once we have the acceleration, we'll multiply it by its mass to get the net force. So let's do this. Okay. So V equals dr dt. All right, the derivative of that would be 3 times 0.020 meters per second cubed times t squared I plus 2.2 meters per second j minus 2 times 0.6060 meters per second squared t, k. And that's our velocity vector. Differentiating one more time, we will get A, this is R by the way, not V. A equals dV dt. And that's going to be equal to 6 times 0.020 meters per second cubed t. That's a constant, I, plus 0 minus 2 times 0.060 meters per second squared k. All right, Let's find what our acceleration is now at t equals 5 seconds. So A at t equals 5 seconds is going to be equal to, I'm going to pop 5 into here and nothing there. So we've got 6 times 0.02 times 5 this is 60 meters per second cubed I minus 2 times 0.6, 0.12, I'm sorry, this is meters per second squared. Meters per second squared, K. All right, that's our acceleration. F equals ma. F equals, m is going to be 2.8 times 10 to the 4th kgs. And then A is this, 60 meters per second, I, minus 0.12 meters per second squared, K. So F is going to equal 2.8 times 10 to the power of 2.8 times 10 to the power of 4 times 60. This is going to be equal to 1.68, 1, 2, 3, 4, 5, 6, times 10 to the 6. And that's going to be newtons, I, minus 2.8 times 10 to the power of 4 times a negative 0.12 minus 3,360 meters, newtons again, newtons K. All right, and that is the force on it at t equals 5 seconds. Okay, next problem. Next problem says, an object moves in the positive x direction with an initial speed of 9 meters per second. So the positive x direction, my velocity is v naught sub x equals 9 meters per second. The surface is flat and there is no friction. At t equals 0, a force, F of t, is applied, it equals 6.00 newtons per second squared times t squared is applied to the box in the negative direction. So we'll just put that there. The box weighs 19.6 newtons. Weight equals 19.6 newtons. How far does the box move from its position at t equals 0 before coming to rest? Okay. All right, now we need to know how far the box moved from its position before coming to rest. So, I have an expression for force here. I'm going to divide by mass to get an expression for acceleration. So mass equals weight over g equals 19.6 newtons divided by 9.8 meters per second squared. That's going to give me 2 kgs. 2 kilograms. All right. A of t equals F of t divided by m equals negative 6.00 newtons per second squared times t squared divided by 2 kgs. And that's going to give me a negative 3.00 newtons per second squared times t squared. All right. Now we're going from acceleration to position, and we are going to want to integrate this time. All right. So we have v equals the integral of a dt. So we have the integral of negative 3.00 newtons. I'm sorry, the units changed here. I divided by kilograms right here, so I no longer have that. So let's think of what units we have. For example, newtons divided by kilograms. A newton is a kilogram. Meter, newtons over second squared, my bad. All right. Newtons over second squared divided by kgs. A newton is a kg, meter over second squared, and then I've got that 1 over second squared, and then that's all over a kg. So these go, so it's a meter over seconds to the fourth is our new units. Okay, and then times over 3. Oh, wait a minute. Okay, that's our new unit there. So I have 3 meters over seconds to the fourth dt. So that's going, t squared dt. T squared dt. And that's going to give me negative 3.00 over 3 meters over seconds to the fourth t cubed plus c. All right, c will be obtained using initial conditions. So I know v at 0 is 9 meters per second. So if I go ahead and put 0 in here, my v is 9 meters per second. That will make c equal to 9 meters per second. So c, we will just change this to 9 meters per second. All right, so that's my expression for velocity. Position, x equals the integral of v dt equals the integral of negative 1.00 meters seconds to the fourth t cubed plus 9 meters per second dt. And I'm going to get here, that's going to equal to negative 1.00 over 4 meters over seconds to the fourth times t to the fourth plus 9 meters per second t plus c. All right, my initial conditions. The problem states, how far does the box move from its position at t equals 0 before coming to rest? I will call its position 0. So at t equals 0, put a 0 here, a 0 here, c will equal 0. All right. When the body is at rest, my velocity equals 0. So that's how I will solve for my time. I'm going to set this expression up to equal 0 and solve for t. 0 equals negative 1.00 meters seconds to the fourth, seconds over seconds to the fourth, t cubed plus 9 meters per second. All right, I'm going to subtract 9 from each side, and I'll get a negative 9 meters per second equals negative 1 meters seconds to the fourth times t cubed, and these negatives will go, divide both sides by 1 meter over seconds to the fourth, and I'll get that equals t cubed. Take the cube root of that, so the cube root of 9 seconds cubed equals t cubed, the cube root, right? So that equals t. And t will equal 9 to the power of 0.33. 2.06 seconds. So I'll write that here with my other values. All right, fantastic. All right, now to find my position, I'm going to take my time that the object is at rest and put it in here. So, x at t equals 2.06 seconds is going to equal to negative 0.25 meters, seconds to the fourth, times 2.06 seconds to the fourth, plus 9 meters per second, times 2.06 seconds. And let's see, what do we get here? All right. And I get 14. 14 meters. 14.03 meters. And that's how you do this problem. All right, next problem. I think I'll stop here and do the next ones on a separate recording. All right.